Today, I am going to discuss Hund's rule, which is related to electronic configurations. In this lesson, we are going to learn Hund's rule with some examples. So, let's begin. Hund's rule, which is related to electronic configuration. Now, let us see electronic configuration of nitrogen. Atomic number of nitrogen is 7. It means it has 7 electrons. Electronic configuration is 1s2, 2s2, 2p3, 7 electrons. Let us see electronic configuration of nitrogen in box method. 1s orbital, then 2s orbital, then we know p subshell contains 3 orbitals, 1, 2, 3, 1s, 2s. These 3 orbitals are named in this way: 2px, 2py, 2pz. Here 2s orbital is a higher energy orbital than 1s orbital, and p orbitals are higher energy orbitals than 2s orbital. That is why these orbitals are showed in this way. Now let us distribute these 7 electrons in these orbitals. 1s orbital contains 2 electrons in this way, in the opposite spin. Then 2s orbital. Now p orbitals contain 3 electrons. Electronic distribution will be in this way? No, this is not stable electronic configuration. Stable electronic configuration is these 3 orbitals will be distributed in these orbitals one by one first, with the spin of same direction, and these 3 orbitals are known as degenerate orbitals. Orbitals with same energy are called degenerate orbitals. In case of degenerate orbitals, electrons will be distributed in this way. Initially, one by one electrons are distributed with the spin of same direction. Actually, this matter is known as Hund's rule. Hund's rule is, in case of degenerate orbitals, electrons will be distributed in such a way that the maximum number of electrons will be in unpaired state with the spin of same direction. This is Hund's rule. Now, let us see electronic configuration of oxygen. Atomic number of oxygen is 8. It means it has 8 electrons. Electronic configuration is this: 1s2, 2s2, 2p4. Total 8 electrons. Electronic configuration in box method in this way: 1s, 2s, then 2p, 1, 2, 3. 1s orbital contains 2 electrons. Then 2s orbital contains 2 electrons. Now 2p orbitals contain total 4 electrons. These 4 electrons will be distributed first one by one with the spin of same direction according to Hund's rule. Now another 1 electron will be paired in this way. This is according to Hund's rule. Now let us see another example. Neon. Atomic number 10. 1s2, 2s2, 2p6. Now, let us see electronic configuration in box method. 1s, 2s, then 2p orbitals. 1s orbital that contains 2 electrons. 2s orbital that contains 2 electrons. Now, 2p orbitals contain total 6 electrons. 6 electrons will be distributed in this way according to Hund's rule. First of all, electrons will be distributed one by one with the spin of same direction. Then another 3 electrons will be distributed as pair according to Hund's rule. Electronic configuration of chromium. Atomic number 24. 1s2, 2s2, 2p6, 3s2, 3p6. After 3p, 4s orbital will come according to Aufbau principle. Then 3d. Up to this, 2, 4, 10, 12, 18. 18 electrons. Here too, 20. Last 4 electrons will enter these 3d orbitals, but this electronic configuration is not stable electronic configuration. Not stable because this orbital is not half filled, not full filled. So to be stable, one electron of 4s orbital will shift to the 3d orbital to be 5 electrons. Now, this is half filled, this is a half filled orbital, which is stable electronic configuration. Now, let us see in box method 24. 1s, 2s, 2p. 1s, 2 electrons. Then 2s, 2 electrons. Then 2p. Total 6 electrons. According to Hund's rule. In this way. Then 3s, 2 electrons. 3p, 6 electrons. 1, 2, 3, 4, 5, 6. Then 4s that contains 1 electron. Now 3d. We know this subshell contains total 5 orbitals. 1, 2, 3, 4, 5. And these 5 electrons will be distributed according to Hund's rule in this way. First of all, one by one, with the spin of same direction, according to Hund's rule. This is electronic configuration of chromium following Hund's rule. Hund's rule, which is named after German physicist Friedrich Hermann Hund. Hund's rule with some examples. Thanks for watching.